Section 11.4. Let's say you want to solve the equations like this. Solve 3x is equal to 6. So you understand, in order to solve the x, you need to have x by itself. So I need to divide both sides by 3. So x equal to 2, right? What if you have equations like this? Solve for x, and you have ax equal to b. So instead of numbers, you have letter. It makes no difference. You still need to have x by itself. So I divide both sides by a. So x is b over a. Let's say we are asking you to solve it for a. So in that case, if we divide both sides by x, so a is b over x. So like this one, w is 64 pi square, and we ask us to solve it for the s. Or in these equations, this equation is given. We always give you equation. This equation is given and ask us to solve it for r. All right, so let's look at the first problems. So what I need here is just s by itself, or s2 by itself. So I don't need 64 pi. Therefore, I divide both sides by that. So now I have s2. S2 by itself is equal to that, but we're looking for s. So normally we take square root of what you have on this side. In this case, you don't need a plus or minus, because we don't know what the values of w pi are. So what is the square root of that? Then 64 is 8 to the power of 2. 8 comes out of the radical. See, you have s is equal to that. So the only difference is here, you're solving it for a letter rather than dealing with the numbers, but process is very similar. Okay, on this one, we want to solve, this formula is given, right? We want to solve for r. So what I do is first I cross multiply. FR2 is that. Since I want to solve for r, I want to have r2, I don't need this f. So I divide both sides by f. So now r2 is that. And this is r2. I need to solve it for r. So then I take a square root of both sides. Okay. So they are using different formula that apply in chemistry, nursing, or other field. And they want you to understand how to isolate one letter and take other variables on the other sides. Solve for G. So first, we score both sides. You understand when you score both sides, the radical is removed, because radical times radical. Okay, well, radical x times radical x is x. Radical mg times radical mg is mg. So we do that first. We raise both sides to power of 2. Radical mg to power of 2 means this. So you don't have, by doing that, you're removing the radical. And since we want to solve it for g, we need to divide both sides by m, because we don't want this m sitting next to g. So g is what? T2 over m, because here you have the g only. Same thing here. I want to solve it for A. So I don't need M2. Because of the plus here is not division anymore. First is a subtraction, means you need to move positive M2 to that side. So you subtract. A2 is equal to that, but we need to solve for A. Then we take a square root, okay? On these problems, number 5, it said an object thrown downward from 200 miles cliff traveled 52.8 meters in 2 seconds. What was the initial velocity? This formula is given. Initial velocity is this V0. Okay, they want us to calculate V0, but the time and the distance of S are given in the problems. So time is given, S is given. So you take those numbers and plug into the formula. T is 2 to the power of 2. So V0 is the only unknown here. I need to move 19.6 to the other side by subtracting. To find V0 by itself, we divide both sides by 2. That gives you the velocity, initial velocity. Problem number 6. During the first part of the trip, a canoeist covered 95 kilometers at certain speed. He then traveled 45 kilometers at a speed that was 4 kilometers per hour slower. If the total time for the trip was 8 hours, what was the speed of each? Okay, so for these problems, the first part of the trip from A to B, let's say from A to B, a speed is unknown, but the distance is given. Then the second part, he reduced the speed 4 kilometers per hour. So the speed is reduced and the distance is 45 now. So for the first 95 kilometers, he drove with a speed of V, which is unknown. The next part of the trip was 45 kilometers and he reduced the speed. And the total time for entire trip from A to C is given. Now, first we want to calculate the time from A to B. Now, the formula is this. Time is distance divided by speed. And that came from the original problem. Like when we say we are driving with 60 miles per hour, when we say a speed is 60 miles per hour, means the distance per hour is the time, or time is distance divided by a speed. So we get this formula from, if you drive every day, you're dealing with that formula. A speed is 60 miles per hour. A speed is 60 miles is the distance, divided hour is the time. Or you could just replace these two and say time is that. So time from here to here is distance, which is 95 divided by V. And time from here to there is 45 divided by T minus 4. See, T1 and T2. The total time is 8 hours. So you take these two and you substitute here. And the rest is just the calculations that you have to take a common denominator. See, you go from here to here. You take a common denominator between these two, and then you have that. Then you cross multiply 8 times that is equal to what you have at the top. This has a long solution. So you do all these calculations till you finally reach to this equation, which is a quadratic equation. You solve it, you come up with two values, 19 and 2.5. We do not accept 2.5 because then if 19 is the V, right? The speed is 19. The other one you have to subtract 4, so the other one is 15. That's why I cannot take 2.5 here, because if you say speed is 2.5, how could you subtract 4 from 2.5? It give you a negative one. That's why we don't accept this. So speed is 19 and the second one is 15. And then this next one is number 7. A car traveled 200 miles averaging a certain speed. If the car had gone 10 miles per hour faster, the trip would have taken 1 hour less. So for this one, so it goes with 200, time and B are unknown. But the set, if we go the same distance but go 10 miles faster, then we have 1 hour less. So time is again distance over speed. Here also for this one, time is distance over distance. In this case, time is t minus 1. The distance is 200. The speed is 10 miles faster, and the second one is 200 over v. This time is, so what we do here in these problems, you have these equations, okay? You take this t and you substitute here. You take this 200 over v and you substitute for the t here. So now when you do that, with this equation, you have only one variable of v. So we take the common denominator here. We cross multiply. It has all this. These two cancel. Anytime I want to solve the quadratic, I rather to have a positive for the first part. So I'll multiply everything by negative to make this negative positive. And then I use the quadratic and I come up with two answers, 40 and 50. And the velocity is 40.